ಪ್ರತಿಷ್ಠತೆ ಕೊಡಬೇಕು ವಿಜಯ್
Where ಕಾಣುದು म्यूट कर ले
Hello.
बोल मैथिली बोल
We'll be starting shortly.
ठीक है शेयर करना स्टार्ट करते हैं
I request everyone to keep their phones on silent. Good morning, everyone, and welcome back to day 2 of IC2TMA 2026. I am Maithili Gosavi, student of FIMCA, and I'm honored to be your host for today's proceedings. To begin our second day on a spiritual and auspicious note, we shall commence with Saraswati Vandana, seeking blessings of Goddess of Knowledge to guide our discussions today. So, I call upon Janhavi to chant Saraswati Vandana. या कुन्देन्दुतुषारहारधवला या शुभ्रवस्त्रामृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिर्देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा निःशेषजाड्यापहा निःशेषजाड्यापहा. Thank you, Janhavi. To recap our opening day that was conducted yesterday, we held a high-profile inauguration led by Chief Guest Dr. R.M. Chitnis sir. We were also privileged to have guest of honor Mr. Rahul Thorat sir grace the occasion with his address. The sessions showcased global expertise with Mr. Basheen Kar sir delivering a keynote from California. The momentum continued with an online session by Mr. Connor McDonald sir on vectors and AI and a series of parallel paper presentation sessions. Today, we are breaking the physical boundaries and going fully digital. We are starting our morning with a topic that is on everyone's mind, applied AI. Joining us all the way from Redwood City, California is Mr. Sandesh Rao sir, the Vice President of Applied AI, Oracle USA, enlightening us on the topic AI everywhere, what's really happening and what comes next. Mr. Sandesh Rao sir is a visionary in the field of intelligent automation dedicated to building the next generation of AI-driven reasoning systems. He specializes in the cutting-edge intersection of retrieval augmented generation and autonomous agents. As a leader in AI innovation, Mr. Rao sir's work focuses on transforming how global businesses interact with data, integrating large language models and knowledge graphs to create scalable, enterprise-ready solutions. In today's session, he will bridge the gap between AI as a concept and AI as a real-world tool, exploring how platforms like Oracle Cloud infrastructure are shaping the future of work and study. Please join me in a warm welcome for Mr. Sandesh Rao sir.
Thank you so much. Really appreciate it. It's always fun to talking to all you guys. My name is Sandesh. For those who do not know, I've actually worked at Oracle for almost 27 years and on AI probably for the last 7 to 8 years. And lately, I'm actually responsible for building agentic solutions And there's a product we've released called the Private Agent Factory. And that is a product I'm responsible for. And I'm also responsible for the Vector Cloud Services product. I'm going to share my presentation if that's okay.
स्टॉप कर दो स्टॉप
Yes, sir. Yes. Hello.
All right. You have to approve my sharing.
शेयरिंग का आई थिंक आई एम एक्सपेक्टिंग ऑल कंप्लीट शेयर शेयर एंड
It says the host isn't allowing sharing. I think you've clicked on decline by mistake.
also
Sorry, sir, for that. Could we
Well, this is like, how many technical people do you need to solve a Zoom problem? The real answer is at least 10 people. This is not as easy as it looks.
Sir, could I request one more? We won't do this again. Sorry.
Yeah.
गाइड कर लो गाइड
You just have to turn on sharing. That's all. So until then, I'll tell you this, that AI is a very interesting topic. And I've had a chance actually to work on some of the cutting edge AI work, agentic work, especially for the last 1 year. And I will talk about, sorry. So I will talk a little bit about what are my experiences and some of the new topics that you must have heard about.
Sandesh sir, could you
Yeah.
just please share again? I'll allow it from our end. Could you just please do the process?
It says, no, okay, give me a second. No, if I do sharing, it says the host isn't allowing sharing for this meeting. So once you decline, no, you have to go and re-enable it from your side. I can't send another request until you enable it. Yep. So there's a lot of content. I haven't put that much into my slides, but I will try to talk about all these topics. Some of you are probably on the cutting edge and are familiar with this topic. All right, there you go. Whatever you did worked. Can you guys see this?
Yes, sir. Yes, absolutely.
All right. So it's like, how do I start a traditional greeting? It has been a long time. I'm actually a Mumbaikar. तर मला मराठी बोलायला येतं, पण आता काय झालंय, इतका अभ्यास नाहीये मला. चालू करू का? All right. So first, let's talk about what AI does. So AI basically changes everything, and it's like the last 1 year I've had a chance to work on this. It has been a significant difference between what happened 2 years ago with ChatGPT and what we are doing today in terms of the different kinds of models and things like that. I think the first thing I will tell people now is you have to basically transform yourself into an AI leader. It's the attitude, it's the thinking. If you basically feel like you have to change yourself, you have to adapt to these new tools, then you will be successful. I think that's the first thing to recognize in this journey, that whatever has happened to us before this is a very different time compared to what is going to happen going forward in terms of the AI tools that are actually available. So what are the main things from a shift perspective that I see? So first of all, the shift to AI systems, because people are just moving from just models to fully end-to-end intelligent systems. Now, what does that mean? People earlier were just asking ChatGPT questions. Now they're building agents. Now they're using Claude Cowork. Now they're building end-to-end ecosystems with agents, with design tools, with building presentations dynamically. So it's no longer just asking questions. It's actually using AI to do your work. There was this tool called OpenClaw, which came out just like barely 3 months ago. And that allows you to run continuous agents over a period of time. And that completely changed the way people actually do things. You can have an agent running, continuously checking your email, answering your questions. You can have an agent continuously doing security scans of your software without you intervening. And you can say, once you've figured out what the vulnerabilities are, actually code fixes for those vulnerabilities and check this into your software. So there's a whole move going on from just using ChatGPT like models to fully intelligent systems. 2023 was the year of vectors. 2024, 2025 became the year of ChatGPT and models. 2025, we started going into agentic. Now we're in agentic workflows and plans. So the agents not just execute chat, like chatting was the first level to go. Now the agents plan, they act, and they iterate continuously, right? So there's a complete change in the way agents work. For the first time, enterprises are adopting AI. So AI is not just like in like consumer space. Enterprises are using AI for security. You must have heard about Mythos, which is Claude Mythos, which is the latest model that they came out with. And everybody's like they found, because it's a code model, it is so good at finding security vulnerabilities that people actually got really scared and they said, "Oh, we're not going to release this model in public because we think it's going to be used to hack all sorts of systems." And people are using this to integrate this into their systems to be able to find vulnerabilities. So actual companies are actually using these softwares into their core AI workflows. So it is completely changing the way corporate works. Then we're going to a multi-model world. So depending on what you're trying to do, you will use different models. Some models are very good at vision. Some models are very good at text. Some models are very good at mixing text and vision. Some models are very good at agentic tool execution. There's different kinds of models that are there. Earlier, the larger models were required for doing something. Now there are at least 3 to 4 additional categories of models. So first of all, there's something called a quantized model. A quantized model is basically the same model, however, using a smaller number of bits to basically store information about its layers. This reduces the quality of the model a little bit, but it reduces the size of the model significantly. So quantized models can be used to perform the task at about 80%, sometimes even 90% of the efficiency of the larger model. An example is I could have a model that is 70 billion parameters, and I could have a model that is 7 billion parameters, which is about 70 to 80% as efficient as the 70 billion parameter model, but requires only 10% of the space in memory for actually doing this. So we live in a multi-model world. People are using local models. If they want to save money, they're running models on their local GPUs to do this. So that's also a significant change this year. The most important is security, because AI introduces new attack surfaces. Cybersecurity is the biggest space that all of this AI actually affects now. People are getting hacked left, right, and center because hackers don't have to learn how to code and find security vulnerabilities. They just have to know how to illustrate a bunch of prompts, and they can orchestrate massive issues on top of these environments. So that's the security angle. Now, one thing that everybody keeps asking is, what is an AI agent, right? So it's a system that basically plans, reasons, iterates, uses tools, and makes decisions with minimal human intervention. There are 3 aspects that tie into this whole thing. User requests, like signals, which are user requests from chat, events that trigger from systems, a ticket gets filed, a row gets inserted, a WhatsApp message comes in. These are triggers. So this context can come from applications, from documents, from collaboration tools, and policies and constraints and goals. So these are the signals actually that trigger agents. Then there's the engine of the agents, which are basically the large language models or the usual frontier models. There's 3 main models, actually 4 main models. There's Gemini, there's Grok, there's ChatGPT, and there's Claude. All the other models are smaller models, but these are the 4 main frontier models that continuously keep pushing ahead. Then there's this thing called workflow orchestration. So you can actually build end-to-end workflows using models and existing application logic that you've already had in your company or your college or whatever that you have built. And that planning and reasoning logic can be reused across the LLM or the agentic pipeline. But there's also memory and state management. So why is memory very important? And I'll talk a little bit more about this as I go deeper into the presentation. Memory basically means there's short-term memory, there's long-term memory, there's procedural memory, there's episodic memory, and there's semantic memory. These are different kinds of memory that get generated as part of an agent execution. When you generate, say, for example, semantic memory, this is all your previous chats. When you ask a question, the chatbot answers. Then you ask another question, the chatbot answers without asking you the same question as before. So it remembers what you're basically doing and uses something called AI vector search to do a semantic comparison of the question and tries to return the answer based on the context that you've given it. If the conversation is long, then you have to store this context in what we call long-term memory. Sometimes some of this memory is procedural, which means it's like, oh, how do I go and open up a classroom? So you go to this location, take a key, find the classroom, open the door, clean the benches. So that's a procedural thing you do. And procedural memory is what is actually used to remember these kind of things. So memory and state management is extremely important as part of an agent. And finally, the execution, which means what does the agent do? Calls APIs, and runs enterprise services, writes and reads data, updates tickets, orders, and produces responses. So these are the three most important things you have to remember about an AI agent. What does it do? It basically operates on signals. It uses its engine to decide what to do with this, and it executes a certain set of API services or produces tickets or sends a WhatsApp message, and that is the execution layer. Now, the most important thing, all this started off in 2023, 2024 with this thing called AI vector search. AI vector search is a technology that is used to search through multimodal, which is documents, images, text, and any kind of unstructured data based on the semantic meaning of its data. So normally what happens is when you're looking for something, you're looking for keywords, you're looking for data in a database. In this case, imagine if you could take an image and convert it to AI vectors, and you insert those vectors, and then you ask questions and compare your question to the vectors that you have stored. Those things are called AI vector search. The power of this thing is this small little vector, which is like a sequence of numbers. Okay, it's a sequence of numbers that are called dimensions, and you use something called an embedding model to generate these vectors. And then once you have these vectors, you can compare these vectors to the vectors you have stored inside your system. And it gives you something called semantic content. Now, what does semantic content mean? I can say, show me drinks. And in that, I have wine as one of the drinks. But, the computer doesn't know that wine is a drink. But if you do a vector comparison, it will actually pull those details out. So vectors, they basically store meaning. They don't just store the value of the words. Like if I have a row that says wine, and if I look for a drink, the row is not going to be returned. But if I actually go and query and I say, show me wine, if it's a vector search, it will actually go and show me any drink that's a wine or whiskey or anything it pulls back. So vector searches basically store the semantic meaning of this. And it's best solved when you combine these with relational problems. But let's take this step ahead. Everybody's heard of relate augmented generation, and that's called RAG. And what you do is you take data that's basically stored in documents, you pass them through a document loader, then you split them, which is chunking, summarization, and you use something called an embedding model to insert these vectors into a vector store. And then you use an LLM in combination with this vector store to do RAG and answer questions. This is how most chatbots work. Okay, so they have this entire unstructured RAG pipeline, and this is basically how it ingests all this information and will respond back depending on. So if the best thing I can do here is say I ingest a cookbook, I can actually click and ask and search for recipes. So that's how powerful this thing is, and you normally can use a RAG pipeline for some of this stuff. Now there's an agentic framework I work on, which is called the Private Agent Factory. So when you ingest documents, there are three parts that come into this thing. One is called contextual retrieval. Contextual retrieval is semantic search. And depending on what question I have asked, it executes a semantic search and retrieves the corresponding vectors associated with this semantic search. Then it goes to the LLM and returns the answer. So you can see here, I've asked a question and it basically returns the answer from some document it has ingested. Then there is grounded responses. Grounded responses are very important for any search because it tells you the source of where this particular thing came from depending on the guardrails. And then it has a whole bunch of connectors associated with it. So this is a typical RAG system where you ingest documents and you ask questions based on these documents and use AI vector search for this. So the first is you basically take a question, you ingest it, you convert it to a vector. Then you take the vector and search the vector database store. You combine it with product information. Then you connect to a large language model, and then you ask this question. And then you return this question back to the user with the answer that you have got from your vector search and your product information. This is how most IT systems work. When you're asking for support tickets and support automation, most of these things work like this. Some of the other applications I've seen for this is people ask scanning, or like a jewelry shop scanning its images, and then someone comes in with a photo of a new necklace, and they scan that image, and they find images of similar necklaces. Your KYC in your bank, when you go there, you put a signature, right? They scan the signature through optical character recognition. And then once they use OCR on the image, they scan it and pass it through a RAG pipeline. And they say, is this image similar to the image that was recorded when you opened up the account? And they do signature KYC matching using this vector technology. So these are some of the use cases where you can use vectors. But what about generally, like which models to use, right? So generally GPT models, which is ChatGPT, they're really good for general reasoning and ecosystems. And so this is one of the places that you will actually use this for. The Claude models, they're really good in coding and long reasoning tasks. The Gemini models are really good in multimodal and long context. So because their context is more than 1 million tokens, and they're multimodal, which means you can insert an image, ask a question, all of these things you can do. Image, audio, text, and you can move between this. That's basically multimodal. And you can have benchmarks. You have to use benchmarks to basically measure the reasoning and coding performance of a model. Every model has something called a scorecard. So if you don't know how good a model is, every day you see there's a new model that comes up, right? Like, oh, ChatGPT 4.5.4 has come out. Now Claude Opus has come out. How do you know which model is better? Because there's a series of tests, just like how in the university you have exams and you have scores for every exam. There are benchmarks and exams for these models. Like there's humanities last exam, right? Which is basically a bunch of professors who basically asked some complex questions on physics, chemistry, and a whole bunch of places. And that is answered by AI, and they grade the answers depending on how those questions were answered. So there's multiple benchmarks that are actually used to answer these kind of questions. So a benchmark or a scorecard is how you can identify how good a model really is. Then there's routing strategies. There's something called Open Router. If you don't know which model to use, Open Router tends to solve that problem for you. So you can ask a question and it redirects the question to the model that will actually give you the best answer. Or the best, it satisfies the situation that you have asked this particular question for. Example is, give me the cheapest model. It'll automatically identify which model is cheaper. Or I say, I have a coding task. I identify the model that provides the best coding task. It will route it to Claude. I'll say, give me something which can handle large documents and a long context. It will give you Gemini. So that is called an open router layer, which basically can send the information automatically to the appropriate model to do things. But in agentic systems, what are the new things that are there? So first of all, the most important thing with agentic systems is tool usage. These agents interact with APIs, databases, tools, and these agents have been getting really, really good at doing all this. But most agents are now multi-agent systems, which means there are multiple agents collaborating on tasks. They are not a single agent. So these multi-agent systems, they kind of talk to each other. So there's a master orchestrator agent, there's multiple sub-agents, and the requests keep moving across them. Based on when you have multiple agents involved, there's something called a planning loop. The planning loop is an iterative reasoning exercise, and that basically helps you improve outcomes. What does that mean? That means that the model iterates through and starts thinking of what should I do next. And there's something called a prompt processing stage. So the LLM has 3 stages. There's prompt processing, there's the actual processing of those tokens and layers, and then there's token generation. These are the 3 stages of processing of information inside an LLM. When you're doing the prompt processing, it basically tries to figure out what it's trying to do using iterative reasoning. Should I do this or should I do that? Now, some models have reasoning, some models don't have reasoning. All the frontier models have reasoning. The smaller models that you can run on your phone and all these things, they may or may not have reasoning because they don't need reasoning. They do simpler tasks. So models that do simpler tasks do not need reasoning, like answer a question on a chatbot. Models that do maths, code exercises, cyber hacking, they need reasoning. Okay, so that's what planning loops are. And then the real world use cases of these agents right now, which is coding, research, and any kind of automation tasks. There's also physical AI. These things are used to control motors in robots. You see in robots running faster than humans. I think in the next 1 or 2 years, we're going to find robots everywhere because of artificial intelligence and what these things are capable of. So automation tasks. So there's one thing you've noticed is in India, when you see people, working in factories, right? They're stitching and all that. They have cameras on their head. The camera is looking at what the person is doing with their hand and training a model. So tomorrow a robot can also do it. So these are real world use cases of how autonomous agents are actually capable of doing things. But I told you before, memory is very important. Short-term memory is very simple. You have a conversation with someone, the last 10 or 20 conversations you remember, that is the context window that basically stores the initial or the immediate reasoning state. But the long-term conversation, long-term memory is also very important. Now, you remember, I mean, if I ask you a question about what you did when you were a kid, you suddenly remember that. Now, you specifically have the capability of going and pulling out that piece of memory from however long you are thinking and remembering everything. So our neural network in our brains is extremely good at retrieving long-term memory, like what you did in school or what you did when you were a kid and things like that. AI agents are very good in short-term memory, but they are really bad in long-term memory. So when the context of an AI agent is populated with too much of stuff, then the long-term memory becomes too large, and it confuses the agent as to what do you really want to do. And that's why anytime you're chatting in chat GPT, it always starts a new chat. A new chat means the old context is moved out and forgotten so that it can provide you better answers. So agents are not really good with long-term memory, but there's a lot of papers and studies going on to improve this process. Vector databases, I've already told you that it enables semantic retrieval. Memory compression tends to reduce, or summarization tends to reduce the cost of memory. There's a lot of stuff happening in this space so that you can store more memories. Like if I say I drink tea, I drink coffee, I drink this, I drink all these things, I can say this in my memory. I will store that this person drinks hot drinks. That's it. I've reduced the context to a smaller set of words. And that's called memory summarization. In addition to this, you can compress the memory, like how you do a zip file. You can compress the memory and store this, and it takes less an amount of storage. Now, the most important thing is how do you maintain accuracy? Like if I ask you, what was your score in 12th standard? You might remember. But if I say, what did you have for breakfast yesterday? You may not remember. The challenge is how do you retrieve the accurate memory fast and without and what's actually pertinent to the conversation. That's a challenge for the current agent memory systems. Now there's something called a KV cache. Any LLM has got multiple layers in terms of a neural network. The KV cache is a key value store, which is basically a cache that works in conjunction in an LLM. The KV cache stores this optimization, and whenever you ask more questions to an LLM, the size of the KV cache increases. This is the most important reason how an LLM today works. It stores what they called as attention states for inference. Now, the attention states are extremely important because if you want fast responses, the KV cache actually functions. The biggest bottleneck, though, is the memory bandwidth. Because the KV cache, the larger it grows, if the memory bandwidth is not as good, the LLM takes longer to respond. Okay. So there are many optimization methods, from compression, pruning, reducing the total KV cache size, including using flash attention, which is an efficient attention computation mechanism that makes LLMs faster. There is a new project that was recently announced by Google called TurboQuant. What TurboQuant does is it basically reduces the total number of bits required for storing this memory, and it uses quantization to reduce the size of the KV cache without impacting the performance or the accuracy of this thing. So you can Google TurboQuant, and it's a very recent project by Google, and it allows you to reduce the size of this KV cache. Now, why are we doing all this, right? So everybody knows today that buying a computer is very, very expensive. Why? Because memory is very, very expensive. Because there's a shortage of memory. Why is there a shortage of memory? Because we are building data centers. Why are we building data centers? Because we need massive amounts of compute to run all of this. What kind of compute do you need? You need GPUs. Why do you need GPUs? There are two kinds of things. You do training and you do inference. Training is when you change and train the model and you're actually altering the weights of the model. Inference means when you're just asking a question to the model and you're generating some kind of an answer. These require two different kinds of chips. The training chips are different, the inference chips are different. The inference chips are easier to make. The training chips are much, much harder to make. Most of these training chips, they use something called unified memory. The unified memory allows you to get extremely high levels of bandwidth between chips and the memory itself because they're actually on the same physical die. So when that happens, you can get something like 800 and something 60 gigabytes per second of speed just between the memory and the GPU. Okay, that's extremely fast. And as a result of which, a system that has that kind of speeds can give you 70, 80 tokens per second from the LLM. All this is done using KV cache optimization. Now, if the KV cache optimization succeeds, you need lesser memory to store the same model. Okay. So that goal is all these optimizations are to reduce the memory so the memory becomes cheaper. That's the whole reason why all this is currently happening. So that's KV cache. Then there's fine tuning methods. So all this started with machine learning. Okay. With fine tuning methods. So PEFT is a method for efficient fine tuning without fully retraining the model. So what you do is you take about 1% of the weights and you train them. And then you say, just use the same training method to train the rest of the weights as you go through it without loading the full model in memory. This is a very fast way of doing training for the models without actually fully retraining the entire model. Another one is RLHF, which is reinforcement learning with human feedback. What tends to happen is whenever you're asking questions, humans are used to train these models to become better and better. Now there's a new thing, which is reinforcement learning with AI feedback, which is the second one, which is RLAIF. This allows you to first train using humans, and then an AI can be used to train another AI to basically align these models closer to human preferences. Then, how do you train all this stuff, right? All the data on the internet is already consumed so far by all these frontier models. Now, if they want to generate new data, they use AI to generate synthetic data. So synthetic data is not real data. So like if for example, if I'm doing something, I want to construct a college system, okay, and I want to do lectures and all these kind of things, and I want to construct an artificial set of lectures, not real and all. I can ask the AI to generate a synthetic data with names of fictitious courses, fictitious names of teachers, and I can use that to train my model. So you use synthetic data to generate data that improves your training scale. This is happening a lot because all the real data on the internet is getting consumed by these models and trained really, really fast. Now, everybody remembers DeepSeek, right? DeepSeek was one of the first distillation models. What is a distillation model? When you basically ask lots of questions to a large model, take the answers you get back from that, and you train a smaller model. Now, you can make these small models really good in a small set of topics. Okay? The idea behind this is we will have these small models running on our phones for doing a very specific set of tasks where you cannot run these extremely large 70 billion parameter models. So these are called SLMs, and SLMs are the future. You'll find SLMs everywhere, inside traffic signals, running inside a car, running on your phone, running in your computer, running in your shoes. When you're running, it will track your running activity and give you advice. Your glasses, everything will have these small models. And this is called edge computing. And all this comes from distillation from larger models to construct smaller models. So whenever you're playing with these models on Hugging Face, which is where you download all these models, you will see models which have quantization. Quantization is a method to basically preserve the accuracy of the models without actually storing all the weights. So the size of the models will be significantly reduced. The most common quantizations are 4-bit and 8-bit. The higher you go, the higher the quantization, the larger the model. If you go to one, there are even 1-bit models, but they're extremely limited in terms of what they do. So if you go below 4-bit models in terms of quantization, then the models are extremely limited in terms of reasoning and what they do. But that's how distillation is also done. So DeepSeek was the first model that used distillation to a large extent. Now there's all the Asian models, Kimi K2 thinking, DeepSeek, Sarvam, all these are some kind of distillation models that are built from these larger frontier models like OpenAI and like Anthropic. Some of these, so people actually ask, how big are these models? Some of these models are as large as 10 trillion parameters. That's why you need so much hardware to run these kind of things, because these are extremely complex models. And then you can choose as a decision strategy whether you should use tuning or prompting versus using an agent. They're all different ways of doing the same thing. Fine tuning works on machine learning models, and then prompting works on LLMs, and agents also use LLMs. So there are different ways of kind of trying to solve the same kind of problems. The most important thing in agents is for calling functions with external systems. There's MCP, which is Model Context Protocol, which is the most common protocol that's currently used for accessing models. There's these have execution capabilities, which means these model can run code and queries. This whole thing works like an AI operating system. All of these are actually AI operating systems. And they're really good because their error handling is critical for production use. They have to have extremely high reliability. So very rarely that you will see Claude or OpenAI down. So that's very important. So the agent is only as powerful as the data it can basically access and the actions it can actually take. So sometimes what happens is some agents are not just using RAG. They use a combination of data retrieval methods and retrieval augmented generation. So when I'm asking a question, the question could contain multiple questions, and I can break these things down and ask sub questions. And I can ask those sub questions, use vector search for one thing, use an LLM for something, and get the top K plans, and then pass this question back to generative AI and answer these questions. These are what real world agentic systems basically look like. They're not just one technology, they use multiple technologies, multiple LLMs, using LLM as a judge to improve their response to be able to do these things. So that's called a reasoning RAG agent or a deep research agent, where the agent does reasoning and retrieval and uses methods like Monte Carlo, executes a tree of thought where it actually breaks down these workflows, does retrieval planning, reasoning, query decomposition, as well as context-aware prioritization to process this. The whole layer looks like this. I've already spoken about memory. I've already spoken about the knowledge base, which is where all the vector ingestion is done. And then the agentic reasoning layer, which has a prompt store and guardrails. So this is typically what a high-level reasoning RAG agent looks like, where it uses an agentic RAG flow. This is the product I work on. It's called the Private Agent Factory that you can use to build agents. And I'll have a QR code at the end if you want to play around with the software. This is what an agent building looks like. So in this case, this is the high-level agent here, and these are the sub-agents that have been built. So each of these sub-agents is connected to REST APIs or MCP servers to execute this, and they return back this response. So this is basically quick byte multi-assistant agent. So think of it as I ordered a pizza and my pizza is late and I want a refund. It's like Swiggy. And it will verify my order. It will look at the refund policy. It will say in Pune, if the pizza is late by 30 minutes, how much money to give back. Then there's a refund processing agent. And then it checks if I'm a frequent person who keeps buying. It'll say, oh, here's a 20% discount for the next meal you take. So these are the agent flows that you can actually build. Now, when you build agents, right, the last 2 years, people started off with LLM chatbots, just asking chatbot questions. Then you went to RAG applications with documents. Then you build LLM-driven workflows, and then you finally land up with agentic AI. I'm going to skip a couple of slides here because I want to get to some of the later parts. So security is actually very important. Prompt injection causes agents to be manipulated. So you can actually ask wrong questions. It's like, hey, show me the salary of my boss. If the agent doesn't have guardrails, it can return some of these answers. Data leakages. When you do not insulate your APIs enough, these this data can actually be leaked to the LLM, and then they train on your data sometimes. So you could lose data. Access control for tools and permissions, and sandboxing, which means you control where the tool is executed, how it is executed, and which environment it's executed in. And basically, you have a zero trust policy, which means no component is basically fully secure, and you cannot trust anybody when building security in AI agentic systems. The different kinds of compliance data, audit trail data, PII data, all this has to be secured when you're doing governance. This is very, very important for any institution. Without this, you might be basically handing over all your data to some kind of AI which is not secure. So the things in the AI governance are policy frameworks. You need to have human oversight. So it's called human in the loop. Human in the loop is when an agent takes help of a human during the process of which should I do this or should I do that? Is this the question that you wanted? Then there's model versioning. Whenever models keep changing, you track the changes in the model. And the most important is ethics. You have to make sure that the deployment is fair and safe and not biased. For students, what do you do? This is kind of like this by the way changes every now and then, but I kind of feel that these things are fairly consistent. Math, computer science, and statistics never goes out of fashion, because this is kind of the bedrock of everything that is happening right now, even with AI. Understand complete AI pipelines. Okay, you can't think of one problem, one piece of the problem. You have to understand the full pipeline of what this thing is going to be built. Have hands-on skills, build agents, create GitHub repositories, build your own applications, right? This is extremely, extremely important. Ethics awareness. When you're building something, build responsible AI. Make sure this doesn't harm people. Make sure it's not biased. Make sure it's not giving responses that are biased towards a certain person or a certain category of people and stuff like that. Continuous learning. This is extremely important. I mean, a lot of this stuff is obvious, but people sometimes do not really follow this. Continuous learning, which means anything that you have to adapt to all this change, because this AI industry is actually moving extremely fast. For future skills, prompt design, which means crafting effective AI instructions, knowing how to talk to these models, managing and processing data, this data management skills, right? Data analyst, extremely important. System designers, like architecting solutions, right? Building chips, building data centers, and all of these kind of things. Security awareness, anything in cybersecurity, because you're understanding risks and protections, as well as in combining different domains. Don't learn one kind of a domain and say, oh, I'm done, and that's it. I'll only learn this thing. You have to be interdisciplinary, which means you need to know multiple domains so that you can tie problems together in the AI space. So what's the future of work? AI copilots assisting us daily. We already have this. Automation. Excuse me. Automation, it reduces repetitive work. That is happening more and more in the coding space, in the testing space, in the space of call center automation and things like that. The creativity focus, where humans actually focus more on innovation and not repetitive tasks. There are new roles being created as we speak. These are AI-centric careers, which are very different from any jobs that were actually created before. And there's constant skill updates required. When some of us were studying, one thing we would study, it would last for at least 5 or 6 years. Now you study a piece of AI, it's obsolete in like 1 month. That's how fast some of this stuff is working. To conclude, systems over models. So this integration of how do you use AI with your problem you're trying to solve matters more than just knowing what a model does. The agents are rising. So systems, these autonomous systems where agents are acting as doctors, agents are acting as teachers, agents are acting to do tasks. Robots will be walking around and cleaning houses. All this is happening right now at an extremely furious pace. Security is critical. Risk management is absolutely essential. And students have to adapt, which means there's a completely new era of skills required for this AI era. So as teachers, as educators, right, this is extremely important for us to understand where this world is moving and how do we educate our kids to adapt for this new era. Earlier, we'd say, okay, learn computer science, Java, you're good for 10 years. That doesn't work anymore. And AI is going to be everywhere. There's going to be no industry that is not going to get impacted by it. Some industries faster, like coding and all, anything digital will get impacted much more faster. Anything physical will take some more time, but eventually there will be methods, there'll be machines, there'll be robots for doing all sorts of physical work as well. So all industries are going to get impacted by using AI. So at Oracle, where I work on, we basically work with all of these supporting leading models and frameworks. Uh, as a student, as an educator, you should get yourself familiar with as many of these frameworks. You should use Claude Code. You should get used to ChatGPT. You should use Gemini for all these frontier models. Many of these models have generous free tiers. So you should be able to use all of these things to be able to answer questions. And the Agent Factory, which is the product I work on, if you use the right side QR code, you can basically go click, set up a lab, and do this entire exercise yourself and build agents on top of Agent Factory. Thank you so much. I hope this was useful to everyone.
Thank you, Rao sir, for that futuristic and thought-provoking session. Seeing the real-world applications from your lens has truly been motivating for all the aspiring developers here. Thank you so much.
Thank you.
If anybody has any questions, you can ask.
Don't be shy. There's a lot of questions that AI folks have for AI, for sure. And I can tell you, there is every question has a long answer.
Hello. Hello, sir. So my question.
Yep.
How do agentic AI ensures data privacy, like handling environment variables, and what are the best practices for it?
That's a really good question. I think all of this data privacy related stuff is extremely important. So what you have to do is when you're using agents, you need to have end-to-end governance as part of the tools. Like what we do is we basically build basic security protection around these tools, which users can query them. Do they have the privileges for asking these questions? Can prompts be injected and guardrails have to be inserted into the agentic system? When the agents go call the tools, do these tools have the privileges to query this data? All basic security is followed at all layers. All communication that happens within the agents is all secure. All the prompts that go into the LLM, you make sure the LLM is not training on your data. So that way, none of your data basically leaks. All the LLM providers, they have something called an enterprise version of their platform, where you can say that I don't want you to train on my data. I just want you to answer questions. And that way your data doesn't leak to the LLM. All the data should be stored in some kind of a database where you can have access control. And then all the tools should be secured with OAuth 2. So you can have OAuth 2 based privileges for authentication and authorization with single sign-on. Once that happens, that same privilege gets into the database and it allows you to only access the rows that you want. And you turn off training on the LLM so that none of your data leaks into the LLM. That way you can seal up and make this agentic query much more secure. It's a very good question.
Thank you, sir, for the detailed explanation.
Any more questions, guys?
Good morning, sir. As students of computer applications, I have a question that as we are entering
Mhm.
the AI workforce, where AI is transitioning from co-pilot to agents, what is one foundational skill that we should have to be the architects of the system rather than just users?
You have to understand how to solve problems. I think that's so. So here's a fundamental difference with how we used to learn things, right? Earlier, when you're learning things, you acquire skills. And the fact that you know skills, it means you know something. But that nowadays, acquiring a skill is not enough. applying that skill to the problem that you're trying to solve is actually more important. So if you ask me today, like, oh, I should learn this, oh, I'm a Java expert, I'm a C# expert, that doesn't matter, that doesn't mean anything to anymore today. They'll ask you, what problems have you solved? What is your GitHub repository? Show me the applications that you have built. So applying yourself to the problems, you can say, look, I had this problem at my university. During the lunchtime, there's long lines and some people did not get food because they were late. I want to figure out a way of how to measure how many students are in line using facial recognition and automatically tell the cook that there are some extra people that are coming. So by the time their turn comes to come to the food, extra food can be cooked. So you're solving problems using AI and not just saying, oh, I'm just going to learn this thing and I will apply this skill. So the ability to solve end-to-end problems and visualize the solution is more important than actually learning the technology of how to do all of this stuff. So that's the biggest shift that's happening. I'll give you an example. I sat and I vibe coded a paratrooper game in 10 minutes. This is a game that I used to play as a kid. And the other day I just got bored and I said, okay, I'm just going to sit and code this particular paratrooper game. And all I had to do was like, look, I'm not a gaming programmer, right? I just work and I build this stuff. So this, give me a second. This is 10 minutes of coding. This was completely built using a local Quen model and without any gaming knowledge. I just want to tell you, this is what I used to build earlier, but I've forgotten all the coding exercises. And just with like 10 prompts and 15 minutes of an LLM, I built this game. The visualizing, it's very important to visualize the conditions, define your prompts. Like if you're trying to solve a security problem, what kind of security problem you want to solve? How do you want it to solve it? What are the guidelines? What are the parameters? That's what's more important than actually writing code. So that's a shift. That's the biggest shift in terms of what you will experience.
Okay, thank you, sir.
Mhm.
Thank you, sir.
By the way, that game is called Paratrooper. We used to play that game as a kid. So it was fun to watch.
Thank you so much, sir. We appreciate you joining across the time zones.
Thank you so much. It is always a pleasure to chatting with you guys and hope to see you guys soon sometime. By the way, I had put up my LinkedIn. If you have any questions, if you want to connect, please feel free to ask. Thank you.
Thank you, sir. Now we'll take a moment until our next speaker joins the meeting.
Thank you. Thank you, Sandesh sir. It's a very eye-opening session for all of us. Definitely we'll try to learn out of your whatever you have delivered today. And thank you so much for your giving your valuable time to us. And we'll see you soon when Oracle Yatra is there in Pune.
Yeah. Thank you so much, you guys. It's always good to see all of you.
Sorry, sir.
Thank you.
Yes.
मेरा चालू है कैमरा चालू है मैम फॅन कमी करते हे बघ फॅन कमी करायचं
आपण मागची टेबल काढणार आहोत तर पूर्ण काही
मला इकडे बोल लागतो नाही बसू शकत त्याची त्यांना दोघांना तिकडे पाठवतो ना आता ते थांबतील तिकडे
फोन पण नाही
नाही ना ते काहीच नाही नाही थोडस बस पुढे नाही नाही, काय नाही हल्लं नाही. हल्लं नाही, नाही 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 नाही, मी हे बघते पार्टिसिपेंट. ती सरच नाही अरे येतील सर, साई सर पण गेले. ते थोड्या वेळ पुढच्या नेक्स्ट टाइम तिसरं सेशन पण फर्स्ट याला आले ते. हा, ते ऐकण्यासाठी आले ते. शेअर केलं ना तू? हो. तेच ना. सुरुवातीला फक्त त्यांनी केलं फोन लावली. कालचा भारी होता तो. कोण? बंद करायला लावलं इथे सगळे जण येत होते. सर गेलो तिकडे, पण तेच म्हणलं त्याला त्याला बसवत नाही. फोटो काढतात ना मग, अरे मैथिली तुझे फोटो काढतात पुढनं काढते का नाही, दर्शन होणार का नाही? हा, अरे मैथिली दर्शन नाही भेटला का नाही? हा? बसायचं नाही मला, सर्व 24. आणि आवडेल. हो हो, येस मॅम. तेच ना. कॉल वेतनांचं आपल्याला जास्त टाइम नाही, 3-3.5 आणि तास, एक तास 1.5 तास पुढे फक्त. 1.5 तास पुढे फक्त, जास्त सकाळचे तिकडे पण आले. मॅडम सर आले. हो, केलं पण हे करून गोष्ट. पण तुझा पहिला वर्ड स्टॉप शेअरिंग कर. नाही
Mani sir, can you hear us?
Yes.
Yes.
We are keeping global momentum growing. As we fly across the map to Ho Chi Minh City, Vietnam,
Stop video and stop.
it is a distinct honor to introduce our next speaker, a distinguished academic leader, educator, and researcher with over 25 years of experience in higher education. Dr. Majo George Sir is the Dean of the Faculty of Economics at the University of Economics and Finance in the Ho Chi Minh City, Vietnam, where he provides a strategic leadership major academic unit comprising over 6,000 students across multiple disciplines. Dr. George Sir has been a visionary architect of cross-border academic diplomacy and a key contributor to the advancement of Vietnam's evolving landscape. As a primary driver of India's
ബാഗിന്റെ അത് കൂട്ടാ വലിയ ബാഗ് മേശപ്പുറത്ത്
Hello. Sir, did you say something?
चुकीने झालं त्यांनी म्यूट केला परत.
He has been instrumental in strengthening international ties, establishing prestigious partnership with the Indian Institute of Management and Indian Institute of Technology, and leading public and private universities globally. Under his leadership, his university recently launched the International FinTech Center, a platform designed to foster innovation in digital transformation and sustainability. His strategic oversight extends across curriculum innovation, executive education, and university industry collaborations that champion applied learning and real-world impact. A prolific researcher and mentor, Dr. George Sir has published extensively in Scopus and ABDC Index journals. His expertise spans the critical intersection of international business, supply chain management, and fintech. Beyond the classroom, he remains an active contributor at the nexus of academia, industry, and policy, dedicated to faculty development and quality assurance. Please join me in welcoming a true global leader and educator, Dr. Majo George Sir.
Hello, good morning. Can you hear me?
Yes, sir, we can hear you.
Okay. Distinguished chair, esteemed colleagues, respected industry leaders, dear students, and all other participants. Once again, very good morning. It's a privilege to join you in this conference, a gathering that reflects not only academic excellence, but intellectual curiosity at its finest. Allow me to begin with a thought, not a statement. For centuries, humanity has defined progress by the tools we created. But today, we stand at a moment where the tools we have created are beginning to participate in our thinking. And that changes everything. We often celebrate artificial intelligence for what it can do. It's faster, it's scalable, it's remarkably precise. But perhaps we are asking the wrong question. The question is not, how powerful is AI? The question is, what kind of relationship are we building with it? Because for the first time in history, technology is no longer external to human cognition. It's beginning to interact with it, shape it, and in subtle ways challenge it. Consider this. A doctor today may rely on AI to detect patterns in medical imaging. A financial expert may depend on algorithmic insights to guide decisions. An educator may increasingly work alongside intelligent systems that personalize learning. Now, in each of these cases, something profound is happening. expertise is no longer singular. It is becoming shared. And when expertise becomes shared, authority must be redefined. The core idea is to form from use to partnership. We are moving quietly but decisively from using machines to working with machines. This is not a technological shift, it's a philosophical shift. In my recent research, I attempt to understand this transformation not as a trend, but as an evolution. What emerged was a four-stage maturity model of human AI collaboration. Allow me to walk you through it, not as a framework, but as a journey. Stage one, assisted intelligence, where efficiency begins. At this stage, artificial intelligence simplifies work. It automates, it accelerates, it reduces effort. But it does not challenge human thinking, it serves. And in doing so, it reinforces a traditional hierarchy. Human leads, machine follows. Now let's look into stage two, augmented intelligence, where influence emerges. Here, artificial intelligence begins to inform decisions. It defines patterns beyond human perception. In one clinical setting, for instance, artificial intelligence systems have detected early signs of critical illness well before physicians could intervene. Not as a replacement for expertise, but as an extension of it. And yet, this introduces a subtle shift. When artificial intelligence informs decisions, it also begins to shape them. And when something shapes decisions, it must be understood, not just used. Now let's move to stage three, collaborative intelligence, where boundaries blur. At this stage, the distinction between human and machine contribution becomes less visible. We begin to write with artificial intelligence, design with artificial intelligence, even think alongside artificial intelligence. This is no longer assistance, it is co-creation. And here lies a deeply philosophical question. If ideas are co-created, who truly owns them? Stage four is autonomous partnership, where responsibility expands. At the highest level, artificial intelligence systems operate with increasing autonomy. They act within defined parameters, but often beyond immediate human intervention. And this is where the test really begins. Not of technology, but of human judgment. Because the more capable artificial intelligence becomes, the more essential human wisdom becomes. Allow me to state this clearly. AI does not reduce the importance of humans. It redistributes it. And in that redistribution, our values shift from execution to judgment, knowledge to wisdom, information to meaning. Let me ask you something. How many of us already using artificial intelligence in our daily work? Whether it is research, teaching, answering your assignments, or any further decision making, or even simply replying emails. Now, let me ask a more difficult question. How many of us truly understand the implication of that use? That gap is where the future will be decided. We often speak about technological disruption, but the deeper disruption is human. We are facing four fundamental tensions. Number one, speed versus understanding. Artificial intelligence moves faster than we can reflect. Number two, accuracy versus accountability. Artificial intelligence can be right, but cannot be responsible. Number three, efficiency versus empathy. Artificial intelligence optimizes but does not feel. Number four, data versus imagination. Artificial intelligence learns from the past. Humans can imagine what does not yet exist. And this is where our role as educators, students, leaders, and thinkers become critical. Now let's look at our atmosphere, universities. Universities today are not simply knowledge providers. We are future architects. All of you sitting here are going to be future leaders. And the future demands a different kind of graduate. Not one who competes with our artificial intelligence, but one who collaborates intelligently with it. This requires a shift in how we educate, from memorization to interpretation, from specialization to integration, from knowledge to wisdom. And perhaps most importantly, from teaching what to think to teaching how to think, learning what to think to learning how to think with intelligence beyond our own. From my experience across academic ecosystems in Vietnam, India, and beyond, I have observed something both exciting and concerning. Many institutions are embracing artificial intelligence tools. Very few are preparing human beings for that reality. Because technology adoption is easy. Human transformation is not. And that is where leadership must step in. We must be beyond simplistic questions like, will artificial intelligence replace jobs? And instead ask, what kind of human capabilities will remain irreplaceable? Because that is where the future belongs. Let me conclude with a reflection. When future generations look back at this moment in history, they will not simply see the rise of artificial intelligence. They will see something far more profound. A moment when humanity encountered a new form of intelligence and was compelled to redefine it. And perhaps for the first time, we were not asking what machines could do. We were asking, what does it truly mean to human? The future does not belong to artificial intelligence. It belongs to who understand the responsibility and the art of human artificial intelligence partnership. Thank you. If you have any questions, please feel free to ask. I would like to give the microphone to the floor.
Thank you so
It
much.
does not have to limit to artificial intelligence, but any questions related to higher studies, international education is more than welcome.
Thank you so much, Dr. George, sir. Your insights on global management and technology trends were absolutely enlightening. We are grateful for the expertise you shared with us today. Thank you so much.
So no questions?
There aren't any questions from our side. Thank you, sir.
Thank you. Thank you very much.
Morning, Major Sir. I'm really thankful on behalf of IMCC for collaborating with us for this conference IC2TMA 2026. It was honor for us that University of Economics and Finance has collaborated with us for this conference. So we like to thank from bottom of our heart and thank you for your insightful presentation just now. It will really help researchers and students for their future studies. Thank you. Thank you very much.
Thank you very much, and all the best wishes for the conferences. And as I mentioned you, we are also having a conference in Vietnam in December. I encourage faculty and students to present papers and, if possible, attend in person. So that will be really great experience. So thank you very much once again, and wish you all the best for the rest